Just when you thought spooky season was over, it's not on this channel. One of the hallmarks of our advancing technology is that as it progresses, wherever possible, it has shown a strong tendency to miniaturize. Take, for example, a computer and Moore's Law. But that's not really a law, as there is a hard limit. You can miniaturize and make your transistors denser, but you eventually hit the atom. But far less capable early computers like ENIAC in 1945 took up 1,800 square feet and weighed 27 tons. But compare that to a modern cell phone that can, by orders of magnitude, outcompute ENIAC, and you can put the phone in your pocket. And this is not done yet. Computers can shrink even more than they currently are, and the only thing driving that is utility. Obviously, we can't shrink a car much more than they already are, without making it inconvenient. Shrink it too much and we won't fit in it, and it becomes a remote control tool or toy. But there are many things we can do, including such unsettling technologies as smart dust, where you can sneeze a bunch of nearly microscopic microphones onto the ambassador's desk and do some international spy operations. Just with cameras alone, many of you will remember the first digital cameras and how large they were when compared to the tiny but significantly better cell phone cameras of today. But shrinking formerly large technologies for added convenience still has some avenues to go down, and one of those is space exploration. There, miniaturization is essentially key in most things we could do. Not all. Big still makes more sense sometimes, but many. Take satellites. They are heavy and cost money to launch, so the smaller you can make it, the cheaper it is to achieve your objective. And from that, the CubeSat was born. It's easy to see ever smaller spacecraft being developed, but as they do, they will proliferate. There will come a time that everyone that wants to will have the ability to use a private satellite for whatever they want, particularly in looking at Earth. Obviously, we already do that with GPS systems as far as usage, but the next step are cameras that you can control, and even private space telescopes can be envisioned for astronomy. It's all about dropping launch costs, which is happening, and how many people will pay to use such services. But there is a much greater, bolder aspect to miniaturization in space, and that is interstellar travel. Every truly viable way we have at our stage of development to travel within reasonable timeframes to another star benefits greatly from and depends on the idea of microprobes. There are several such ideas out there, an example being the breakthrough starshot concept of using a laser-driven light sail to make the trip. You build a huge laser, put some microprobes in space with light sails, and then drive them to another star, and decades later, perhaps centuries in practice, you get a flyby picture of that star system. Possible for sure, but more or less on indefinite hold right now. But there's a newer and extremely innovative approach, it being the TARS system introduced by Dr. David Kipping, linked to his video detailing the idea at the Cool Worlds channel, and to an Event Horizon interview I did with him on the topic, both well worth a watch. But what's really interesting there is that it does not just hold the chances of flinging a microprobe to another star system at high speed, it does so shockingly inexpensively. But in either concept, the probe or probes must be very small. More probes would be good. Not only does that give you more chances of at least some of them surviving the trip, but also spreading the measurement capabilities of the system across more platforms for redundancy and editability. You will learn more, and you have more built-in safeties for your mission this way. The days of science fiction ideas like Battlestar Galactica-style gigantic starships probably is not the route we should go if we ever develop interstellar exploration, at least early on. We will much more likely do it on the scale of the miniature. Indeed, our trend of ever more sensitive technology that is growing smaller may be very telling. If you think about it, we need to emit a lot less radio energy now than we used to, even though the practical need for it is greater than it ever has been. This is because you do not need hundreds of watts for a cell phone transmission. You just need enough for the highly sensitive tower to pick it up. But the trends towards miniaturization can also be seen as a trend towards effective silence. Imagine for a moment a lighthouse. An old school lighthouse beaming out a lot of energy like a flashlight going over and over to warn ships of a navigational hazard. These still exist, but the days of lighthouse keepers living on site to keep them going are ending. It's automated, but the need for the lighthouse itself is also passing in the age of GPS. Well, that GPS signal for ships does not need to be as powerful as the beam of a lighthouse, because eyes may see the lighthouse, but if it were too dim, they would not. Radio, not so much. Much easier to see weaker signals. It may work like this with aliens and radio. They simply may not emit their signals strongly past a certain point and are now too dim, as it were. This is why we cannot see most of the stars in the Milky Way with our naked eyes, but they are there. But with increased sensitivity, dimness diminishes. This works this way for technology too. This means you can miniaturize your detectors at the same time as making them more powerful and sensitive. Well, undoubtedly aliens, if they are out there, know this too. They too would know the utility of smallness where possible. Sometimes it isn't possible. You can't make a tiny Dyson sphere around a giant star. But some technology, when it becomes possible, you can make smaller, at least until you get too small, and the glories of the atom once again stop your progress. We aren't there yet. But here's the question. Do aliens make themselves, or at least their technology, very small? This is a solution to the Fermi paradox and a solid one. Advanced alien technological signatures, except in cases where they can't be small, may make them invisible even though they are very much there, and very powerful in capability more so than we, but functionally invisible from a distance. This idea is like a minefield, where you think you are walking on solid ground in space exploration in another star system, but then you find that there is someone there, and then kaboom, their actual technological abilities are revealed, and you are reduced to a charcoal briquette. Or alternatively, you may think a star system does not have a civilization in it, so you head out to take a look. And when you are well on your way, perhaps over half the distance, you suddenly come into range and start picking up technological alien signals. If those signals turn out scary enough, you're going to need to figure out how to turn around, which at relativistic speeds is no small feat. You may find yourself trying to squeak by with some solar and planetary gravitational assists to fling yourself out and back towards home from a hostile star system. Miniaturized alien technology may be extraordinarily advanced, but also extraordinarily small and efficient. This might make it basically impossible to detect at a distance, even if that civilization is a galaxy-spanning empire. The functionally silent but highly efficient empire. But perhaps the most spooky idea here is that it actually goes for the solar system as well. Dim alien probes not emitting much, that are quite small, cannot be ruled out as not present in the solar system. The solar system is absolutely enormous. It's as much as 3 light-years across from the edges of the Oort cloud. That gives it unfathomable amounts of real estate where a probe the size of a baseball could sit and remain permanently undetected, no matter how technologically advanced we become. A needle in a haystack is not a strong enough comparison, unless the haystack is the size of the sun. But does it have to be as large as a baseball? Maybe not. Chances are aliens could employ nanotechnology and shrink it even further to be like the smart dust. This would be fantastic for interstellar espionage for sure. And as it stands, we have no way of detecting it if it's happening, especially if the probes are inactive or otherwise very dim and their transmissions are not pointed towards us. And that gives a spooky speculative scenario. From our vantage point here, we may see nothing transmitting from this star system that isn't our technology. But as we send out interplanetary probes, as we are, those probes have to maintain two-way communications with Earth. It's possible if the right alignment happens and the exactly correct technology to see a wide frequency range is there, we could detect an alien transmission coming from within our star system by a probe looking inward at the solar system from afar, meaning that we would then know that something or someone is here. Not a likely scenario for many reasons. Spacecraft tend to be built exactly for a specific mission and only carry capabilities needed for that mission. So more realistic here is if we had a radio telescope array in the outer solar system that occasionally looked towards home, might we catch a faint transmission from a microprobe? But that it would be coming from our own star system and is not ours is a spooky thought indeed. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently looking forward to charging back rent and usage fees to the alien microprobe sitting in our star system. If it's been here for billions of years, well, let's just say we're owed a lot of money with interest by those aliens. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular, in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.